Here, we have to predict the rank that a student may get in GATE based on their performance in BTech. So let's say what are we provided with or what we can infer from the question. So we are given the history of BTech performance. It's BTech performance, which I will mark as B, and we have to predict GATE rank, which I will mark as G. First of all, we are looking for a mapping from two variables, that is from BTech performance to GATE rank. So the key term to focus here is that yes, we are looking for a mapping. And why is a mapping required? Because the variables are of different types. So two different variables. So since it's a mapping, we essentially learn a function, and the function we will learn will be of the form G is equal to f of p, consistent with our notation we have followed so far. Now, what remains is to decide whether we should go for, again, classification or regression. Here, gate rank will be a natural number. So naturally, the possible values are discrete. Let's assume we will only consider ranks till 50,000. Then we can say that the values that G can assume will be between 1 and 50,000. Moreover, G belongs to the set of natural numbers. Now, it's interesting because we have a dilemma here. Previously, we have seen that prediction of continuous values mean regression, and prediction of small set of discrete values typically mean classification. Here, natural numbers are discrete. In fact, natural numbers are countable sets, hence they contain discrete elements. But the number of values to predict is not small. We have 50,000 different values to predict. So what should we do? Should it be classification or should it be regression? So I have two arguments to go for regression. Let's see what exactly would be that. First of all, this is a supervised task. The question does not say how much data we have. So naturally, I am assuming I will need to collect the label data from the past. In this case, I will have to collect the BTech performance and the corresponding gate rank for the students who wrote gate in the previous years. So there is nothing said in the question, but it is obvious that I can't do it without label data because the mapping is between two type of variables. So I will have to go back and collect the data. That is a given. Now, if I have to do this for a classification task, I will need to collect labeled examples for each label. Let's assume I will have to collect 10 examples, 10 labeled examples for each label. So that would mean I would have to collect 5 lakh or 500,000 label data points because I have 50,000 labels. So 500,000 point labeled examples. Even if I'm assuming just 10 per label, and it's costly. Cost need not always mean money, it can be the effort, it can be some other restrictions, like it's an overall resource is costly. So if you consider it as a regression, right, that's where the second aspect comes in. If you look at the label set, which is numbers from 1 to 50,000, that forms a subset of natural numbers, and natural numbers form a total order. So essentially what I'm trying to say here is that I know the relation between every pair of numbers in the set. Say I know that 5 is less than 10. I know that 10 is less than 100. But if you look at a classification task, this information, that is the relation between the labels, are generally not captured in classification tasks. But in a regression task, it can be captured. Hence, I do not need to collect labeled instances per rank. So, in regression, no need to collect data per label. So overall, regression makes sense here. I can achieve a similar performance with lesser effort using regression, and hence I will go for it. The only caveat here would be that we may need to round off the predicted value to the closest natural number post the prediction, because a regression may predict a continuous value even if you don't provide a continuous value. A small correction: by continuous value I mean a real number which is not a natural number. So it may predict a 3.3, it may predict a 5.7. In such cases, I need to round it off to the nearest natural number. So with that caveat, I would go for regression.